Today you will construct and describe direction, form, and strength of scatterplots. Statistics, remember, is often about studying relationships. It tells us how variables will interact with one another. For example, do students that take more algebra classes score better on the ACT? One thing to keep in mind, though, that these relationships are tendencies, they are not rules. So when we look at a response variable, remember it's going to measure the outcome of our study, and it is also the dependent variable. So the response variable is actually what goes along your y-axis. The explanatory variable explains or influences changes in the response variable. This is our independent variable or our x variable. So in the first type of problem that you will see, we want to give the explanatory and response variables. Now you will have a few of these on your upcoming formative. So in number 1, the number of hours studied and the score on the test. Okay, so usually explanatory variable, that's what we place along the x-axis. In this case, you're going to put hours studied for x or explanatory and the score on the test for y. Number 2, the amount of ice cream sold and the outside temperature. This one is a little trickier. Remember, independent variable means I don't have a lot of control over it. So in this case, you will use the outside temperature as your explanatory, and your response variable is the ice cream. Now take a few minutes to try 2 problems on your own. For number 1, you should have said the explanatory variable is your average income, and your response is the life expectancy. Now notice we have a thinking bubble here. Remember, the explanatory is the average income because the amount of money people have to spend on healthcare helps explain average lifespan. So that is the reason why we want to choose income for explanatory variable over the life expectancy. In number 2, this one is a little unique. We have heights of husbands and heights of wives. Husbands is x and wives is y, but this one is really interchangeable. So in this one, the explanatory variable could be the heights of the wives, and either variable is used to explain or predict the other. So in this case, it doesn't really matter. So scatterplot, this is the most common way of displaying a relationship or association between 2 quantitative variables. We measure on the same cases. There are a couple critical things that I'm looking for when you construct a scatterplot for me. The first, I need a title. I need some sort of context title. I need a horizontal label for the explanatory variable, a vertical label for the response variable. And then notice we have these horizontal and vertical scales. They need to be consistent, like a number line. And then you have your various points. So when you are interpreting scatterplots, you're really looking for any overall pattern or overall deviation or outliers. We use 3 words to describe a scatterplot. We're going to use a word for form, a word for direction, and a word for strength. When we're talking about form, we're looking at overall shape. So we could have the scatterplot, it appears linear, meaning the points look like they're in a line. We could have them be nonlinear, meaning there's a bend in the scatterplot. And then we could have unclear. Now this one on the right, I would still probably classify it as linear. I mean, it looks like you could draw a line through it. But if you were to write unclear in a scatterplot such as this, it should be okay. We also have a word for direction. So remember on the previous slide we talked about form. Sometimes the word shape is used. For our words, we have positive association, meaning if I were to draw the regression line, the slope is positive. And then we have negative association, meaning if I were to draw the regression line, the slope would be negative. Finally, we have a word for strength, meaning how close do the points follow the general form. The picture on the left is strong because we can clearly see a distinct linear pattern. The picture in the middle is what we call moderately strong. We can still tell the points follow the general form. They're just more spread out along the line. And then we have our week, right? It looks linear, but the strength is relatively weak. So in our next example, we're going to create a well-labeled scatter plot to describe the relationship between the amount of sugar and the number of calories in movie theater candy. Then we're going to describe the relationship shown in the scatter plot. Okay, so you have 4 of these in your practice today. First thing, what are we going to place on the horizontal axis? Well, hopefully you see that we are going to place sugar. And then on the y, we're going to put calories, okay? And there's some clues in our story that help us devise this. I like to think of this as an XY table. So this is X, and this is Y. So an XY table, so sugar would go on the horizontal axis, calories would go on the Y. The other thing we need to be cautious of is we need some sort of title. So obviously we're talking about movie theater candy in this example. Now, because our story says well-labeled scatter plot, you need to scale your horizontal and vertical axes. In the sugar column, notice that our smallest number looks like 44, and our largest number is 136. So if it were me, I would either choose to scale it by 10, starting at 40, or you could scale it even as high as 20s. Do that now. For the vertical axis, note our smallest value, it looks like is 350. And our largest value is 680. So I would probably scale that guy by 50, starting at 300, or you could scale it by 100, starting at 0. It's really up to you. So do that now. Now, once you have your appropriate scales, you're going to plot each of the ordered points. So when sugar's 45, I'm going to go 45 on the horizontal axis and up to 450, and then place my dot. And I would do that for each of the candies in the list. What I have for you here is an approximate sketch that you would see either in a computer or a calculator. But if it says well labeled, I want you to graph it by hand. But this should give you a general idea of what your scatter plot should look like. Okay, and in our last example, we're going to practice analyzing the scatter plot. And if we wanted to have a word for form, what would you say here? Hopefully, you're thinking that this graph is linear. Direction. Hopefully you notice that the direction of this scatter plot is negative. And then for strength, we can clearly distinctly see a line, but we have a few of these points that are off the beaten path. So I'm going to say this one is a moderately strong association. And that's it. You're ready for some practice.